equals 3 root 4x minus 1 plus 6. I want transformations. Then I want mapping. And then I want domain and range. Okay, staff check. Transformations.
Okay, Grant, let's go.
You can even just speak them if you don't want to write them. Grant's teaching.
So for the A value, it's 3, which, does anybody know what that corresponds to? Shane?
I think it's a vertical stretch by a factor of 3 about the x-axis.
That is correct. It is a vertical stretch by a factor of 3.
Can you write
But
that
the
out?
x-axis.
I can't exactly.
No.
I've seen his writing. We're not going to do that. Okay.
And then when you look inside the radical layer, there's something you need to do. What is that, Shane?
You can't just pick Shane. That's bad teaching.
No, Shane, you're done. Sam, what do you do?
You gotta take something else.
You take the 4 out of the 1 and the x. And then it's x. What will be inside the bracket?
Whatever for. It's the answer.
And this 4? Does anybody?
I don't know if that was that a yes?
No, it's a no. The 4 is a horizontal stretch, but since it's, inside the, I don't even know what it's called.
With the x?
It's a radical.
Since it's with the x and it's
Yeah.
under the radical,
Yes.
that means you need to flip it. So it's a horizontal stretch by a factor of 1/4 above the y-axis. Then when you go into the bracket there, that's where your horizontal stretch is. And
AKA horizontal translation. Absolutely.
that is what I said.
Yeah.
You can't look at the recording. And since it's with the x and it's a negative, you're going to go the opposite way. So you're going to be going right. So it's a horizontal translation,
Yes.
1/4 right. And then there's the 6, and that's directly the vertical change. Sorry, are you on your phone?
No, actually not. It's my calculator.
Okay.
Where's
That's a
teacher?
very thin calculator.
And then you go up by 6 on the y-axis.
Write that math in.
Yeah.
You can
Pick up a different markers.
Write the map.
Yes.
This is terrible.
That's actually not bad.
The y was okay. Connor, what are you going to do about it?
There.
You can't threaten your students. It's not okay.
Sorry, Connor.
No.
Is there something wrong with this?
You need 1/4 in front of that.
Yeah.
Yeah. Nothing wrong.
I
It's
wasn't
just not
there.
got there yet.
I wasn't there yet.
You don't have to. It's not by like aggressive. It works just fine even if you're like, oh. Okay, what's the domain? Anyone know? Bueller? I would ask her. Just go with
Shannon,
her.
please. What's the domain?
I think if x is greater than, is it greater than or equal to, or is it just greater than? Greater than or equal to 1/4 x units.
Ask her if she said x such that, and then she had said the squiggly bracket at the beginning. You just missed it.
Yeah.
Totally what she said.
I have mine in the squiggly form. I would like to.
But the
So
squiggly
my
bracket.
fault,
Does anybody know the range? Shane.
y such that y is greater than or equal to 6 equals with the squiggly lines.
I never.
You're holding your marker like it's gonna attack you.
It's a weird angle, and I still don't. I still just draw squiggles instead of squiggly
You know what, I
brackets.
take it.
I like how Grant is still wearing Birkenstocks.
Every day this semester.
Every single day.
It's commitment.
It is.
It was like 2 years.
Did you? Okay. Why is it x is greater than or equal to a quarter? Yeah.
Because the like radical with no transformation is usually, I'm pretty sure x is greater than or equal to 0.
Mhm.
So the only thing that changes that 0 value is for the domain of horizontal translation, and then same thing for the y. It's usually y is greater than or equal to 0, and the only thing that changes it is a vertical translation.
Yes, because your radical graph normally looks.
Then reflections will change,
Like
like
that.
the greater than or equal to sign.
Yeah, so basically what Shane is saying is this vertical translation will be the number for your him.
Yeah.
Both you. Both you
Make
two.
them teach next.
That's what's happening. It's real. You know what? This is what you're doing. This is what you're doing. This is what I need you to do. That's closing your phone, throw it out the window. I clicked on the side of the phone. I clicked on the side of the phone. Because don't care. Okay. All right. So, we're missing lots of people, okay? We're just trying to take it in as much as we can here. Okay, with the 6, this here will tell you how much it moved up. So it moved up 6, let's say, so now it's here. And then Shane's right. If this is a plus here, then it's not reflected, correct? So it would still be up and to the right. So that's why it's greater than or equal to 6. This here means it moves right a quarter. So now it's like right a quarter, so it's like here. And it's still positive, so it didn't reflect. So now it's here. So it's greater than or equal to a quarter, and it's greater than or equal to 6. Yes. Good. Okay, that's radicals. Can you put the test away? I fear you're going to use them or something, and then you just go home to your mama. Okay. Rationals. Actually, I'm going to do one more radical. I want you just to give me the domain and range to this. Ready? Okay, go.
All right, class. Okay. What does this mean?
That's negative.
Jack, I didn't ask you.
That's negative.
So what does that mean?
Did you pick a different color? Because
Oh,
now it just
'cause
looks
it's
like two
equals?
negatives.
Okay, I can fix that.
No, it's
Nope. Okay.
the erasers. No, you just
It's broken.
Can you pick the red marker up? No, pick the red marker up. Put down the eraser. Push eraser.
Why do I have to
Gonna
do
be-
that?
Because it's my board's being not fun right now. Okay,
Well,
you can pick any color from up.
That's not
Pick any
my
color from up there.
what color should I pick, class?
Or yellow, so you can't see it.
Okay, so
Did
basically,
you just pick
so
red
what,
again?
so what is this?
Oh my gosh, pick a different color.
Okay, I picked
Where's
black.
teacher at?
So that means
Okay.
what? That means what again, Jack?
It's reflection.
Okay, thank you. A reflection where?
This side.
No.
Wait, no, that's not the question I
That's
asked,
not
actually.
reflection in
I
the.
think it's yes.
Okay,
in it.
yep, sure. And then this, do I have to show the like mapping and stuff? Yeah, I do.
No, you just have to do domain array.
Oh, okay. So, okay,
That's
yep.
gonna help you with what?
This is, yeah, what is this gonna help us with, class?
Define.
Jack?
Vertical, no, stretch.
There
Yes,
we go.
but
Okay,
that's helpful to domain array.
okay. Which one do I want to do first? We're gonna do this one first.
I would do range
Are you
since
giving me
you're-
two?
I would do range since you were talking about the Y's.
Okay.
That's just me.
Who was laughing at me?
I think
Okay.
it's gone.
All right, so this. All right, so that means it's gonna go this way, right?
Why?
Because reflection. And
Why are you explaining?
Jack explained this to me.
Okay, good.
And then, this is not looking very, there we go. Okay,
It's less than or equal to ask class. Your
class,
teacher.
what is this less than or equal to?
6.
Jack?
Ask someone other than Jack.
Okay.
Yes?
What? 1? Okay.
-1, he said.
Negative
And he's
1.
right, yep. Why, Jack?
Why, Jack?
Why? I was still not like that.
Hint.
It's because it's at the end of the bus.
And it moves.
That's good, but
down.
Yeah, there's more to it.
It
Okay.
moves down 1. Okay, then why you are squiggles.
Yep. Oh, that's a.
Yep. Wow.
There you go.
Oh, rest squiggles. Okay.
Okay, now we're gonna do domain.
Maybe ask someone else to help you.
I'm good. Oh, well, I need them to step up to the plate.
You will then ask who wants to help you,
Who wants to help me?
other than Jack.
Hands, please.
Jack can't help you because good teachers wouldn't ask the same person twice. He's done. You pick someone if they don't help you then.
Mr. Real asked Josh like 5 times in a row.
Okay, well, Josh isn't here, so.
Ask Larson. You know.
Jack. Yeah, Connor, you help me with this one.
Okay. We need help with.
How do you get the domain?
Is it greater than or equal to, greater than?
Well,
Less
are there any
than-
reflections?
He's asking you. You're not the teacher. You're the student. You're supposed to answer. Connor's turning into the teacher.
He's asking me, so I'm asking questions to help him find him.
You can't ask questions. No, he's asking you for the answers. You're the student,
This
Connor.
1/3 is with the X, yeah?
Yes.
So what do we have to do? We have to take it out? Okay. 1/3. Oh my, this is very tight.
I'm
What?
sweating over here. It's stressing me out. Carry on. 1/3. 1/3.
My mom said, if there's nothing nice to say, don't say it at all.
I just said I was sweating. I didn't
And
say
then-
anything about you.
Give me a sec. Fixing it.
Baby eraser.
Okay, why are you laughing at me?
Because you're using the baby eraser. You can use
Marker?
the bigger one. It's fine.
Missed the last spot.
No, it's good.
Okay, so the 1/3 comes out, right? And then what's in the brackets?
We gotta take the 1/3 out of both the terms, so.
Okay, so what's in the brackets?
X plus 18.
Okay, I didn't ask you, Shane.
Sorry, I forgot.
It's taken 8 years.
Good.
All right.
So what's the domain?
So what's the domain?
Connor, what's the domain?
X is an element of X is greater than or equal to -18, X element is real.
Positive 18, yeah. Or negative 18, yeah.
-18. I said negative. Or did I?
Yes.
Oh.
No, you did.
You
did.
did.
You totally did.
Get him confident.
I'm questioning my existence.
Nope, you said negative 18. You're completely correct.
Squiggles. Okay.
Does everyone have that? Now, why did the inequality not flip?
Yeah.
Why did the inequality not flip?
No reflection.
There's no reflection in the y-axis.
I didn't even have this answer.
That's you just good thing he was questioning you and asking you stuff.
Team power.
I believe that Connor should have come here as a teacher because he immediately started doing teacher questions to you when you were asking him questions. Okay.
You obviously need help. I can sense it.
Okay. Rationals. Rationals. So what if I give you this? Y equals 3 over x minus 7. Y equals 3 over x minus 7. X can't equal 7, which is going to be my what? My which asymptote? Vertical asymptote. It's going to be x equals 7 because we know x minus 7 cannot equal what? 0. So x cannot equal 7. The asymptote is where it doesn't equal, right? So you say x equals 7, and that's where the vertical asymptote can be. Now, how do we get the horizontal asymptote from this one?
There is nothing with up there.
There's nothing with up there.
No, I meant like there's nothing
In the
like, there's no
numerator.
vertical translation.
There's no vertical translations at the back.
So it's y can equal 0.
Yes. So when it's in this form, it can be in transformed form when your numerator is smaller than your denominator, correct? So when your numerator is smaller than your denominator, she's saying there's nothing up here, so there's nothing over here. When your numerator is smaller than your denominator, your horizontal asymptote is always 0. Remember, because you can put it in transformed form and you can put the plus 0 at the back. So remembering when your numerator, and we're going to actually go through limits right away, and limits will prove why this is real rather than me just trying to tell you memories. So numerator is greater than the denominator, the degree. Your horizontal asymptote is y equals 0. Yeah.
I'm supposed to remember when I do this stuff.
Yes. Why we're reviewing it right now. Okay.
There's some I don't remember.
Okay. What if we do this? Y equals 7 over x, 2x squared minus 3x minus 2. Give me the asymptotes, please. And the domain of range. So, when I factor the denominator, help me out. So we have 2x squared minus, what multiplies give me negative 2 and adds give me negative 3.
Minus 4x.
Minus 4x plus 1x minus 2 group. What can I take out of the front?
2x.
2x I'm left with.
X minus 2
And then
plus 1.
and then x minus 2. So I get 2x plus 1, x minus 2 in my denominator. Your guys' teaching techniques were like good. Your writing on the board techniques. Okay.
I thought I wrote that diagram was pretty good.
Yeah, I like that.
Lucas just looks super upset. Are you okay?
Oh, really?
Cut down his writing skills. You did a good job. Yeah. Yeah. Writing a little bit needs a little improvement, but the rest really good. Well,
My feelings are hurt already.
actually, looking back, it's not that bad. Looking back, it's not that bad.
Exactly.
I take it back.
You can see everything.
You can. I at the time I thought you couldn't, but now I look back and I see
It was the angle.
it was the angle at which I was sitting. You're right. I retract my statement. Okay. All right. What are the vertical asymptotes at? Seamus, what are the vertical asymptotes at?
And negative a half.
X equals, sorry?
2 negative a half.
Yeah.
That's good.
Now the reason why they're asymptotes. Oh, Jack, my friend. Come on. Come on.
What?
Come on.
What?
Come on. You have to get the vertical asymptote now. You're on your phone. Don't worry, I'll like the markers for you so that you don't stress that. Come on, Jack.
Oh.
Just doing the horizontal. It's not gonna be-
Yeah.
I'll even write the word for you, Jack.
Or you can wear mine.
Oh my goodness, no. I'll write this out even for you because I fear. Okay, what's the horizontal asymptote, Jack?
Good job.
Okay.
Oh my gosh, hard.
That is my name. That's too hard to say. Just say Mr. P. Okay. Horizontal. Oh, we can do more.
Oh no, he's like, he's
Custom
gonna be
color.
so distracted. They can't see
No,
that.
if you go into more, you can make a custom color. And now define custom colors.
What are you doing? Just,
You gotta use
Jack, you just tap on one. Okay. Just tap on a color. Use a tap.
Wait,
Okay, press OK.
nice. Okay. So, horizontal asymptote was the first step.
I think Mr. P, I think it's 0.
It's what equals 0, Mr. P? Ask him.
What equals 0?
I don't know.
No, that's not going to work. Put it down. No, this is not going to work either. Stop it. This smartboard is being, can you put down the, what? Adapt to your surroundings. Use the, okay. Marker. Your color's gone. Enjoy. Okay. What is equal to 0?
Was equal to 0?
What variable?
What variable?
Y.
That was a team effort. Exactly. What is that?
It's a new update.
It's the new update? Oh my gosh. Mr. P, you can't even hold on to your marker. You okay? Push pen, not pointer. Pen. Oh my gosh. Okay. I'm sweating again, guys. Okay, yay! I literally just put down the marker.
Is that it?
Don't go on your phone. All right. Because the numerator is a smaller degree than the denominator, the numerator is degree 1, denominator is degree 2, it'd be y equals 0. Right? Okay. What happens when we have the same numerator and denominator? So we have y equals 2 minus 3x over 1 minus 4x. Okay. Shane.
I'm pretty sure when they're the same degree, you can take the leading coefficients, like the ones that go to the same like highest degree. I'm pretty sure. So like you take the 3 and the 4, and then you would just divide it over, and that would be your horizontal asymptote.
Yes. So the leading coefficients in front of your variable of the same degree would be your horizontal asymptote. And you take the signs with them. So because these are both degree 1, I take what's in front of them, and I get y equals 3/4. And then the vertical asymptote it's going to be x equals what, Isabel?
Maybe -1/4. No, 4. No, wait, yeah.
4.
Yes, because we go 1 minus 4x equals 0, negative 4x equals negative 1, x equals. Yeah, we're there. It's totally what you said. I agree. Okay. I'm calling your mother. I actually know where you live. I know where you all live. I have your addresses. It's a joke.
Nice try. My address doesn't even know it's my house.
Well, you're bad, so I can see why your parents have to do that sneaky address thing. I get it.
Jack changed his name one time on a Google Meet, and I didn't know you could do that. And then he said that he follows me. Yes, he did.
Okay, moving on. So we have, I can't, 2x minus 1 over, I need to go up there and cheat, 2x plus 1 over 2x squared minus 3x minus 2. So the bottom is actually bigger than the top now.
Horizontal asymptote, y asymptote.
It is not.
Huh? It is not y.
The numerator is a smaller degree than the denominator. We have to factor our denominator. When we factor our denominator by decomp, what did we get last time we did this one? 2x plus 1 and X minus 2, I believe. Do you see something that's going to happen?
Oh, they cross off.
They cancel off, and when they cancel off, what do we get? A point of a point of discontinuity. When the numerator completely cancels off, what's left behind? Not nothing, a 1. So I actually have y equals 1 over x minus 2. If I take a break right now and ignore that pod for a second, ignore the point of discontinuity, what am I left with? 1 over x minus 2, which is still irrational, is it not?
Yep.
So what do I still have from this rational?
Vertical asymptote.
A vertical asymptote and?
Horizontal asymptote.
Right. And then I'm also going to have a point of discontinuity, which I'm going to deal with under the blue after. So you can, if after the point of discontinuity cancels, you're still left with a rational, you still have vertical and horizontal asymptotes plus a point of discontinuity, right? So you draw your rational like normal with an open dot. So most people forget when they go to the graph to draw the rational with an open dot. So what is my vertical asymptote here? What's my horizontal asymptote? Y equals 0. The numerator is smaller than the denominator. The numerator doesn't have a variable, so you can put it into transformed form and you could add a 0 to that, couldn't you? Both those reasons. Now, my point of discontinuity. I'm going to go back to that. What did I get from my point of discontinuity? It is negative a half. That's the x. If I asked for the y on the diploma, which you don't have anymore, it would be a standard of excellence.
Right?
You would have to sub it back into
the like new one.
You'd always sub it back into the simplified version. So we're going to get 1 over negative a half minus 2, which equals 1 over negative 5 over 2. And when you have 1 over something, what does it just mean? You reciprocate it, so it's negative 2 over 5. Because you end up dividing 1 divided by negative 5 halves, which is 1 times negative 2 fifths. Right? That's how you get the reciprocal. Okay? You're going to try this one. Try this one. I have to make one up. Okay. So this one I want, paying attention, I want the asymptotes. I want the point of discontinuity. I want the domain. I want the range. Okay? Here's your example. Y equals 3x minus 1 over 3x squared plus 8x minus 3. What I need to remind you about this, please remember that when you're stating your domain and your range, your point of discontinuity, x, and your vertical asymptote, x, both can't equal 2 in your domain. Your range, your y is your point of discontinuity, and your horizontal asymptote both can't equal 2, right? So you're going to get, if you have asymptotes and point of discontinuity, you should have 2 numbers both places that they can't equal 2 for your domain and your range. So try this one out. Get your vertical asymptotes, your horizontal asymptotes, point of discontinuity if they exist, and then your domain and range. So we have 3x squared. What multiplies to give me 8 and adds to give me negative 9?
9 plus 9, that's 10.
Okay, we're going to group them. Take out a 3x, I'm left with x plus 3. Take out a negative 1, I'm left with x plus 3. 3x minus 1 and x plus 3. Okay, so we have 3x minus 1 in the numerator over 3x minus 1, x plus 3. We have one more type to do after this still. So these cancel off and I'm left with the 1 in the top. If I go to do my asymptotes, I have a vertical asymptote at what?
X equals 3, negative 3.
Yeah. Because the numerator is smaller than the denominator, I have a horizontal asymptote at y equals 0. Now, sometimes it's easier as you go along to fill in your domain and range. Wow, it's really lagging. So if I did my domain before my point of discontinuity, it'd be fine. I would have to go x such that x can't equal -3, and y such that y can't equal 0. So those will sit there. And put a comma, because I'm going to end up with 2 more numbers coming along here because of the point of discontinuity. My point of discontinuity is at what?
1/3 minus 0.3.
Is that x equals 1/3. I plug it into the reduced form, simplified form, x plus 3. So I'm going to get 1 over 1/3 plus 3, which is 10/3, which is 3/10. So my point of discontinuity is at 1/3 and 3/10. And then I can go to my domain and say, oh, it can't equal 1/3 and y can't equal 3/10. XER.
Could you write it as like 0.3 for that one since it's terminating?
No, it doesn't terminate. It's repeating. It's 0.3333333.
No, I mean 3/10.
Yes. Sorry, I thought you meant 1/3.
I would have said like 0.3333333.
3/10 you could have wrote as 0.5. Yeah.
Gosh, do you think I'm gonna write 1/3 as 0.
Gosh, I was scared.
You read it as like
That's insulting.
0.3 go half.
No, don't do that. Rate is 1/3. 1/3 is more accurate. Why would you change it to a decimal?
Oh, yeah.
All right. So we have y equals x squared plus 5x. Is that even possible? Minus 6 over x plus 6. I want you to give me, by discontinuity, asymptotes if they exist, domain and range. This one.
There is no. Just kidding. Okay.
Right, so if we factor this, we're going to get x plus 6, x minus 1, x plus 6. The x plus 6's cancel, so we are going to be left with x minus 1. What is y equals x minus 1?
Linear function.
It's a linear function, so this is actually going to be a line with an open dot. That's it. This doesn't have asymptotes. So the last one, the numerator canceled off, and I was left with 1 over something which is irrational, right? So I end up with vertical and horizontal asymptotes. But when your denominator completely cancels off, you're just left with a linear equation. So you're left with just a line, which is going to have an open dot in it. Where does that open dot exist? Well, we have a point of discontinuity. At -6 comma something. So we're going to go y equals -6 minus 1, which is -7. So when I go to get, that's the point of discontinuity. So you draw the line x minus 1, and then you have an open dot on -6, -7. And our domain would just be x such that x can't equal -6, XER. Now, if they wanted that in interval notation, not equaling -6, if you look at it as a number line, that means you have -6 here, you have an open dot, but you have everything this way and everything this way. So basically you have -infinity to -6, round bracket, or, which is the union sign, -6 to infinity. If you had it like the last time, you would have 4 of them. If you had x can't equal 0, -2 and 0, you'd go from -infinity to -2, -2 to 0, so you have 3. -infinity to -2, -2 to 0, 0 to infinity, round brackets. So you count the numbers. The range of this one, in set notation, just keep in mind that when we go to calculus, it turns completely to interval notation. They very rarely do that. And so this is going to be -infinity to -7, or -7 to 6. And it's round because it doesn't equal it. The last little bit, you can go online and do whatever the heck reviews you want to. I posted a whole bunch of different ones. You could also watch my review podcast. I posted most of those in the previous times. Go into podcasts. You can do whatever you want. That's for the last 15 minutes.
And I was just watching all your posts.